Hi there. Let's take a few minutes and talk about question 1515. So in this question, stumps is the number of stumps left as beavers cut down trees. And beetle larvae, this is the number of larva clusters that are located on those stumps. So in part A, we're asked to make a scatter plot that shows how these two variables are related. Remember, when you describe a scatter plot, you should always talk about its direction, its form, and its strength, the strength of the relationship. So here's my scatter plot. Here is the window. I went from 0 to 6 on x and from negative 10 to 60 on y. So here's again the scatter plot. That direction is clearly positive from left to right. It's rising. The form is relatively linear. And I would say this is a pretty strong relationship. Eventually we'll see that that's pretty strong when we look at the actual correlation. However, here's how I wrote about it. Again, on that scatter plot, you should write about those three things. So the scatter plot indicates, in terms of direction, a positive linear relationship. So linear is a way you can discuss the form. And this relationship is strong. There's the strength. Make sure you understand who the explanatory and response variables are. So the explanatory variable is x for explanatory, the number of stumps from trees cut by beavers, and y is the number of larva clusters. This is the response variable. So in part B then, we'll go back and take a look at the output then. We're given the regression output. Here it is. So our next job was to find the least squares regression line and draw it on the plot. So I had indicated just to draw it on the plot on the calculator. So notice though, you don't have to actually run the linear regression in the calculator. Here is the constant. So there's the y-intercept, and here's the slope. So my equation is just y hat equals negative 1.286 plus the 11.894x. That's exactly what I did in my calculator. So there's the scatter plot. We'll go to the y equals menu. There's the equation. I just read it straight out of the computer output. Plot it right on, so not a surprise. It goes right through my scatter plot. So in terms of vocabulary then, the way this question is phrased, what percent of the observed variation in the larva clusters, so that's the response variable, the variation in the response variable is explained by the straight line dependence or by this linear regression on beaver stump counts. That's the explanatory variable. Well, this is describing r squared. So here is the value of r squared. It's 83.9%. And actually, if you take the square root of that, you can get the correlation. So I know the question didn't ask you to do that, but some review. So notice the correlation is the square root of 0.839. That's 0.916. So that's a pretty strong correlation. Remember, correlation is always a number between -1 and +1, and it indicates the strength of a linear relationship. So this is truly a pretty strong linear relationship. Then the last part of the question asks, is there evidence that is strong that the beaver stump counts help explain the beetle larva counts? I told you to go ahead and assume the conditions for inference were met. So we're going to do a hypothesis test on the coefficient of stumps. That's the slope. But notice we're already given a t-score and we're already given a p-value. These are for the two-sided hypothesis test. This p-value actually is so small that to 3 decimal places, nothing actually registers. So understand, let me show you what I wrote then. So we assume the conditions for inference were met. So here's the null and the alternative hypothesis. The null hypothesis is that the true slope is 0. The alternative hypothesis is that the true slope is something other than 0. So again, I didn't have to do anything. I could read it straight out of the table. T is approximately 10.47. You don't have to calculate that by hand. Notice there are 23 observations, so the degrees of freedom is 21. That's important because I used that to calculate the actual p-value on the calculator. And the p-value is less than 0.001. Again, the computer showed 0.000, which means that it's even smaller than 3 decimal places, so it's certainly less than 0.001. So we interpret this the way we would interpret any other test. So with such a small p-value, we can reject the null hypothesis at any reasonable level of significance, say 1%. This is the actual crazy low p-value, and I used the tcdf command to calculate it. So there is strong evidence that the stump count can be used to explain the beetle larva count.